Hello guys, another problem. The problem is simple, but the geometry is not complicated, but you have to work it out. So determine the moment of each one of these two forces with respect to the pin at A. This is the pin at A located right here. So basically what we have to do is decompose this force in the components. You can see here, I'm gonna decompose this force, this component, and this component. And I know this is 90 degrees, so that's why I can do that. This angle here is 30. This angle here is 30. This is 90 degrees as well. This is 60. That means that this is going to be 30 again. This angle here is 30 degrees. So this force is going to be 52 cosine 30, and this is going to be 52 sine 30 degrees. Now we need the distances. Remember, for the horizontal force, I need a vertical distance. The vertical distance between this point and the pin. So I'm going to draw it here. Vertical distance between the force and the pin. That's the distance that I'm looking for. This distance. And I know from here to here is 8. So we need to find this other distance. But we know this is the radius, which is 6. And this distance is 6 cosine 30, which is the same thing as this one. You see, if you focus on this triangle here, it's going to be 6 cosine 30 degrees, because this is 30, right? So this is 30 as well. Or you can say, if this is 30, this side is the one that I'm looking for, which is the same one. Now, if we want to copy that, at least that force, horizontal force, 52, let's say for the force 1, summation of moments at A due to the force 1, to this force. 52 cosine, I'm going to say this is positive. 52 cosine 30, that's going to be our force. Now, how much is the distance from here to there? The distance is going to be 8 plus 6 cosine 30. 8 plus 6 cosine 30 degrees. In what direction? Well, if I apply the force like that, it's going to be clockwise, meaning if counterclockwise is positive, this will be negative. Now, the other force is this one, 52 sine 30 degrees. That means that we need the horizontal distance, this distance, from that force, vertical distance, to the point A. And we know this total distance is 5, but we can focus onto this little piece here, and that little part over there will be 6 sine of 30, because this is 30, right? This distance is the same as this one, and this distance is 6 sine of 30. So that will be sine of 30. Meaning the total distance will be 5 minus 6 sine of 30. That's it. Now the direction. If we study this force, and this is the point A, I put my fingers in the direction of the force. I grab the pin with my palm, and whatever the thumb is applying, that's going to be positive or negative. In this case, it's counterclockwise. Or you can just put your finger there and push it in the direction of the force, and you will see that it's going to be counterclockwise, meaning it's going to be positive in this case. So the summation of moments of the force at A due to the force 1, or the moment at A, better say, due to the force 1, will be 52 negative 52 cosine 30 multiplied by parentheses 8 plus 6 times cosine 30 close parenthesis plus 52 times sine 30 multiplied by 5 minus 6 times sine 30 degrees. So that will be negative 542.27. Negative 542.27. Negative, remember, negative. And that negative, what it means? It means that if I assume that this was a positive direction, clockwise, counterclockwise, and I got a negative, that means the direction is going to be clockwise, opposite to what I assumed it was positive. And of course, it's going to be pounds per inch. That's it. Now, let's work with the other force. If I work with this other force here, F2, same approach, same procedure. I have to find the components. This component and this component. Now, this component here, once again, if this angle here is 20, this is going to be 20, this is going to be 90, meaning this one here is going to be 20 as well. This is 20, this is 20, then this one here will be 80, and this has to be 70, I'm sorry, 70, and this will be 20 again. So this force will be F2 cosine 20 degrees. F2 cosine 20 degrees. And this force, hence, will be 52 sine 20 degrees. What do we need? We need the distances now. What distances? Between the point A and the horizontal force, we need the vertical distance. We need this distance from here to here. And how much is that distance from here to there? Well, the distance from here to here, this distance, it can be found because we have the total distance. Look, if I complete this line here, this total distance is 8, so I need to find this distance. And that distance is what? It will be 6 cosine 20. 6, remember, is the radius. 6 cosine 20. So that one will be 6 cosine 20 degrees, meaning the distance that I'm looking for will be 8 minus 6 cosine 20. That will be the vertical distance for this horizontal force. Meaning, summation of moments at A due to the force 2. And I'm going to assume the same thing. It will be, starting with this force, F2 cosine 20 multiplied by this distance. Once again, this distance is 8 minus this part, and this part is 6 cosine 20. Now, in what direction this is going to rotate? Put your finger, apply the force, it's going to go like that. What is that direction? Clockwise. Counterclockwise, I say positive, so this is going to be negative. Now, for the other force, this force will be 52 sine 20. And the force in this case is vertical, so we need the horizontal distance. What is the horizontal distance? The horizontal distance will be from the point A to wherever the force is applied. This is the distance. Meaning, it will be 5 plus this little portion, but this little portion here is the same as this little portion there, and that will be 6 sine 20. Then what will be the total distance? The total distance will be 5 plus 6 sine 20. Sine 20. In what direction? Once again, put your finger, apply the force in this way, rotation, rotation, counterclockwise. Counterclockwise means positive in this convention. So the force 2, the moment at A, due to the force 2, will be just the result of this operation here. F2 was, I put F2 here, but F2 is 52, right? Yeah, so this is 52 here. So 52 cosine 20 multiplied by 8 minus 6 times cosine 20 plus 52 times sine 20 multiplied by 5 plus sine 20. You see I didn't close the parentheses. Multiplied by 5 plus 6 times sine 20. And that would be something weird. Let's try again. I mess up. Look, here's the error. You see the error? Let me show you the error. You see the error here? I didn't close that parenthesis there. So I can just go up if I want to. Complete the correct closing. Right there. Insert with parentheses, hit enter, and I get 10.01 pounds per inch. Because the result that I'm getting is positive, and I assume this as positive. The result that I'm assuming is positive. Yeah, it's positive. Negative 52 cosine 20 plus 8 minus minus 52. I'm just checking, guys. Minus 52 cosine 20 times 8 minus 6 cosine 20 plus 52 sine 20 multiplied by 5 plus 6 sine 20. Yes, enter. And that would be 10.01. And because this is, I assume, clockwise as positive, that's what we did, right? This one positive, this one is what? 52 sine 20 positive, this one negative, correct? Then the result will be here counterclockwise. And that will be the answer for this problem. Thank you for watching, guys. Keep learning, please. See you in the next video.